I should be audible, I think. Welcome to AVT Core. We are it is whatever time it is. It is 9 a.m. US Eastern, which should be whatever time this is for everybody else. And I guess we're probably ready to get started. Not that all our participants are here yet, but hopefully they will trickle in over the next few minutes. Our current plan is that I will run the queue and Bernard will run the slides. So here you can see, here's some tips on how to use the, how to work in the meeting, this virtual meeting. Hopefully if you've been around this week, you're somewhat familiar with it, but if it's your first meeting, you should know these tips. Importantly, please use headphones because there's been a number of problems with echo cancellation not working well. It's not always obvious who's speaking, so please state your full name before speaking. I'll add to that. Please make sure that when you've unmuted your mic, give it a few seconds to make sure that the audio is kicked in before stating your name, because many people, they say their name but it's clipped. And when you want to enter the queue, select audio, video, or both. Just selecting video will give you video but not audio, which is probably not what you want. All right, next slide. We have some note takers who volunteered. We had Stefan volunteered to take them in Word, and Alexandra, who is not actually here yet, I guess, unless he's using a strange name, volunteered to take them in the CodeMD. Anybody else can join the CodeMD. There should be a link within Metaco, or use the link on the screen. And then James volunteered to be Jabber scribe, though I'm also keeping an eye on the Jabber. If you're in the meeting, you have the Jabber over to the side there, or you can also join via an XMPP client. If you're in Metaco, you know the first link. The recordings will be up there eventually. All right, note well. These are things you should know if you're participating in an IETF meeting. I'm not going to go over the details, but if you have any questions, consult your own lawyer or knowledgeable person. Next slide. So we have a new person up at the virtual front of the room today. Bernardo Bobo, who's running the slides, has now become my co-chair. Thank you to Rachel and Ronnie, who have stepped down. Rachel because she's in a new position, and Ronnie because he has retired. So congratulations to Ronnie for that. I don't know if he'll ever hear this because he's not probably doing any of this anymore. So congratulations to him and enjoy his golf. All right, so our agenda. We had one minor agenda bash since the first version of the agenda went out, which is that we've added a brief presentation on header extension encryption, which there was a long side email discussion about, wasn't on the list, but I'll try to get it public now. So hopefully there'll be enough time for everything else anyway. Other than that, you can see what's on the slide. If anybody has any comments on that, let us know. Otherwise, we'll just press on. So, status of our documents. We've had one since IETF 106, since we didn't meet at 107. We've had one document published, so excellent. We have a number of things in the queue, which are now moving forward in the queue. These are listed in rough order of how far they are in the process. If you're an author on something in Auth 48, please do get your Auth 48 comments in. And yes, I know that includes me. And LRR is in misref on frameworking, which we'll get to in a moment. All right, next. So CC feedback, we did publication request, had an AD review. which had a number of minor comments, all of which seem pretty straightforward. So then hopefully the author should be able to get that done in the next little while. The VP9 payload, I believe, is ready for working group last call. If anybody has, oh, here's Ronnie, who has joined. So I just, repeating what I said earlier, thank you, Ronnie, for your many years of service in this as a chair, and enjoy your retirement. So VP9 payload is probably ready for working group last call. If anybody has any dispute about that, let me know, or let us know, or say something right now. Otherwise, we'll go ahead and do that. Since I'm an author on that, I'll probably have Bernard run that. JPEG XS just had a draft come out, I think 2 days ago. I personally haven't had a chance to look at it, but I had some comments on the previous draft, which it sounds like from their description on the email list, they hadn't managed to, they made some other changes, but hadn't managed to get to my comments yet, which are about the SP negotiation. So, but that seems to be making reasonable progress. The Tetra payload is expired. I don't know how much the authors are, how active they are, but we'll let that continue. And then the one thing I did want to discuss in somewhat more depth is frame marking. There was a working group last call. There was one comment on that, but unfortunately the authors never actually responded to the comment. So I'm trying to figure out what I want to do about that. I think it's been, oh, it's Mo, did you want to talk? I see you're in sending media.
Yes, I can respond to it, Jonathan.
Okay.
Yes, there is an outstanding update that we need to make for Dale's comments, and sorry, I don't think any of the authors have had a chance to complete that. I'll get to that this week and get that.
So I mean, one possibility. I mean, clearly this has been a, shall I say, not your highest priority. Would it be helpful if we appointed a new editor on this to take over these last processes? So just to get it off your plate.
I think the comments from Dale were long, but I think we had already had a pass through. I forgot whether or not we actually discussed it as a group of authors.
Okay.
But I'm pretty sure I've already gone through the entire list, and there weren't any substantive changes, but there was a lot of clarifications that that need to be made to address Dale's comments. I think it'll be quick if I just go through them today and try to get everybody on the same page about the responses and get Dale's approval that the clarifications are okay. So
okay, yeah,
see if I can get that out today.
Yeah, because this has just been lingering for a while, so I'd like to. I mean, if you can get that out today,
I agree.
That'd be the best, and then we can just go ahead and for pub rec. Because this has been lingering for far longer than it should have been.
Yeah, I agree. Apologize for that.
All right. Okay, so that's all we had in the chair slides, I think. So first up will be the multi-party real-time text. Is Gunnar? Yeah, Gunnar is here. So, Stefan, did you want to say something?
Very quickly for the notes, regarding the VP9 payload format, I noted that no one voiced a different opinion regarding your question working group last call. I hope that's
yeah. So I mean, I think, well, yeah. So I mean, my inclination is do working group last call. Probably shortly after the meeting. I don't know if we want to give it a little extra time because we're going to hit European vacations, but then we'll go ahead and do that. And like I said, I'll probably have Bernard run that call because I'm an author on that. And now Gunnar is up for multi-party real-time text.
Yes, hi. Yeah, I have two drafts going in the multi-party real-time text area. And you are handling the slides, so next slide, please. I'll try to expand it so I see it better here. No, it was not the right. So, first, why do we do with this multi-party real-time text and what is the requirements? The real-time text itself, it's text transmitted while it's created, so it's rapid, no waiting like in messaging. It enables smooth conversation, just like voice and video, and it's useful for all, but it has mainly been picked up in accessibility area enforced by regulation. Multi-party was envisioned from the beginning in the presentation standard IETF108-AVTCORE-20200730-1300, but sadly it was not clearly explained how to get the multi-party done when it was specified for SIP in RFC 4103, the RTP-based transport. I guess that was because there are already methods for multi-party in RTP and you could use any of them, but it's good to have an agreement on both ends how to do it. Now there is an urgent need to get this implemented. It's both a push from next generation emergency services in USA and Canada, and it's also required by the European Accessibility Act. So we need to get the description on how to do it. The main current implementations where this is needed is in 3GPP IMS and in next generation emergency services, and also maybe in relay services, video relay and text relay. So therefore, we are now specifying with a goal to have it easily implemented in existing technologies, because we have already requirements, for example, in IMS mobiles. And so the first draft I have is still a personal draft. It's called Multiparty RTT Solutions, and it's on level 02 now. It is an informational draft used as background for specification of the other draft, the standards track draft. So it collects requirements, collects possible transport solutions with pros and cons, so you can follow there why one or some were selected. And there are the single stream RTP based, multi-stream RTP based, and even WebRTC T140 data channel are mentioned there as possible solutions. And for the focus on the standard track is on the single stream RTP based, so there we have a couple of variants. In this overview of the solutions, we also have session control solutions with SDP and centralized SIP conference. We have discussion of various negotiation solutions with an SDP attribute or FMTP parameters or media tags, and conclude that currently the idea is to have an SDP attribute to check that both the bridge and the endpoint are capable of using the same kind of multi-party solution. There is also a chapter of presentation aspects. So I think this is good to have this draft. It is currently a recording of different solutions that have been discussed, and it can possibly be used by developers and in future work. So I would in fact like to see this become a working group draft. But the main focus right now is on the RTP-based mixing. The other draft, which is already a working group draft, it is RTP mixer formatting of multi-party real-time text. So that's a standard track. The main focus is on RTP-based solutions and also together with centrally controlled ZIP conferences, even if that is not totally required. There is also brief information on other aspects like WebRTC transport in the just to become RFC for that part. There are also a bit about gateways, about security, encryptions, and so on, and presentation. So good presentation of multi-party real-time text requires that you have a multi-party aware endpoint that can take action on the incoming text and present it in different areas. So this is a bit different from other media. When the receiver gets it, it's usually already formatted for presentation. Right now, the draft contains 3 kinds of RTP mixing solutions. Maybe we could decrease that to 2. The 3 ones are, number 1 is a mixing for multi-party unaware endpoints, which gives you low functionality. It doesn't switch sources as rapidly as you would like to, but it's needed because there are many clients out there that will not be upgraded to any aware situation when this is first launched. So that needs to be kept. Number 2 is mixing with the current RTP format. The RFC 4103 is the current transport for real-time text, and number 2 is a description of how to use exactly that format for multi-party, which gives you 1 source per packet and mention the source in the CSRC list. Number 3 is a new TextRex packet format where you can have many sources per packet and therefore increase the source switching performance. And we had discussions back and forth between different methods, and I just recently had a move from the high performance solution, the number 3, and also we discussed multi-stream RTP down to have a focus on the rapid and easy implementation in current technologies, the number 2. So that is my focus right now, but I want to seek some advice on that. So next slide, please. When you select method here, you need to have a balance between performance and ease of implementation. The key performance figure in multi-party real-time text is if the time for switching between different senders, and the effect you can get is a jerkiness, that there will be a delay before you start presenting text from another source. So, and there is a figure requirement for 2-party real-time text saying that you could accept a delay of 1 second from typing to presentation in 2-party calls, which is in F700. And it's likely that you have the same kind of requirements for multi-party, even if I don't know any research on that. If you want to follow what one party types, you want to have it in the same kind of short delay or no delay as if you were in a two-party call. So here is an overview of the performance we have per solution. Number one, the fallback, it has a varying delay before it starts to present text from another simultaneous source, usually many seconds, because in that method, it is the bridge that plans the mixing, and it displays whole sequences of text from one party until it finds a good place to break and let another source be displayed. Still, it can be quite good if you have people ending their what they say with return, and also between two users, it will be very good. Number two is, of course, better. That is the one based on RFC 4103. There you will have a jerkiness of about 150 milliseconds when you have two simultaneously sending sources, 300 milliseconds if you have three sources, and 750 if you have four sources. While number three has a very good performance. It only delays up to 150 milliseconds if you have up to 15 simultaneously sending sources. We have also discussed RTP multistream, where you also get good performance with up to 5 simultaneously sending sources. But then if you have more simultaneous sources, then you will get too many packets per second, so you should avoid having more. So how many users can really be expected to send simultaneously? Where shall we put the requirements? And I have to admit that I have so far had a bit too high requirements. The view should be that you have similar expectations as for voice in a conference. Just usually just one is sending voice. In text, you might be able to occasionally have a second source sending, and well, also in voice, you have a second source saying yes or no, or I agree, or I want to comment, very brief comments. But for text, you might have someone typing a bit longer information streams while another one is typing. For example, in an emergency call, I can imagine that you will have people getting anxious and eager to provide more information or so. So they will type, yes, I will clarify something, while the agent is also informing in text. So occasionally too. You might also have language translation sending text, but then there will probably not be more than one sending text continuously. So very rarely more than these two simultaneously sending parties, and the conclusion is that good performance at 3 sending sources is sufficient requirement on this. The other requirement for the current implementation is that it must be easy to implement. And the comparison then is that the number one requires nothing from the endpoints, but it's a bit complex for the mixer, but it's needed anyway, so that need to be accepted. Number two, the RFC 4103 based, it is easy for the mixer. It is easy for current endpoints to add this capability. It is the same packet format as for RFC 4103, just a couple of additions. and an SDP attribute negotiation is added so that you can know that the endpoint is capable of presenting it. And this CSRC is the base for understanding which source is currently represented in the packet. Number 3, the more capable one solution is requires a new alternate packet format called text-to-X. And this is, of course, more complex for the mixer to decide to use this new format with more sources in the same packet, and also more complex SDP negotiation between two packet formats, and more complex for the endpoint that need to be able to handle this new format. So it's likely much longer time to get this acceptable and added into 3GPP and GSMA specifications. Next slide, please. So there we are currently, and I would like to have some comments on the list or in the meeting now. Shall we keep all these 3 solutions or reduce to 2? Number 1 I see as required. It's needed for current endpoints. But number 2 and 3 seem to be overkill to keep both in the current draft. Number 2 seems to be needed for its timeline, and I regard it to be sufficient in performance. Number 3 seems to be not really needed. It's just too good to have for the performance beyond the requirements. So my proposal is now to move on with just number 2 and number 1 and number 2. Future use may also take other directions. For example, it may be more developments on T140 in WebRTC data channel that is already mentioned how that shall be multi-party handled. It's briefly mentioned here, but also in the T140 data channel specification. So that is my next slide, please. Is probably the ending. Yeah, thanks. Comments are welcome now, and of course in the list.
Any comments from the group? Or I can give my own comments as an individual. I certainly think, as an individual, I would say that, I would say, given, the time pressure, certainly the thing that's going to be easier for implementers and other SDOs to adopt, we should focus on that, rather than something more complicated, which might not get uptake. So yeah, I would say yes, let's just go with 2 and then document 1 as the compatibility fallback. The other question I wanted to ask the group is, do people think that the informational draft giving the alternatives and background is a useful document to publish as a working group document? Just giving the rationale and requirements and all that. I had personally thought that maybe it wasn't necessary. It could just be around as an internet draft. But I think given that there's been some discussion, when people review the standard document of why did you take this approach, it might be a useful thing. So if anybody has any comments on that, that would be useful. Anybody? Stefan.
And I found it useful.
You did find it useful?
I found it useful.
Okay, that's one thing for adopting it. I mean, certainly I think that we want to get the actual standard document done first because that's the one that the other SDOs need. But
yeah, definitely.
Yeah, so I mean, we can do a call on the list if people think that adopting the informational draft would be a useful background for the standard document. And then sort of timing-wise, we want to get them both done at the same time, so it can be a stable reference when we publish the standard one, or if we want to try to get the standard one done first. That's the other question, procedurally. Any other comments on that? All right, well, we're a bit over time anyway, so I guess in that case, we will, sounds like the very, loose consensus, which is to say 2 people have said yes, nobody else has said no, is to go with just option number 1 and 2, and to, and we'll do a call on the list to see if people want to adopt the informational document as a working group item. All right, so
Okay.
Justin,
Thanks.
you're up next. Thank you.
Thank you.
Justin, if you keep yourself in the queue. There you are.
All right, how's that?
Yep.
All right. So how much time do I have?
-7 minutes, but nominally 5.
Okay. All right, so RTP header extension and encryption. Next slide. So over the past couple of years, we've accumulated a lot of RTP header extensions in use. This is the output of what Safari actually generates if you just go and create an offer in the RTP. You can see that we've used almost the entire array of 1-byte extensions. And a number of these actually have content. Some of this has been discussed in some of the security documents that has some sensitivity, actual audio levels of speakers that can be perhaps used for some at a minimum analysis of traffic, and possibly even phonemic correction. And there's some other ones that are also sensitive, and even the ones that aren't super sensitive in terms of extracting personal information, at least leak information about endpoints. What type of application is it? Is it streaming? Is it conferencing? What kind of encoder does it have? Does it support HDR, etc.? So it seems like there will be value in encrypting this, in 2020. Next slide. At present, there's a fair amount of unencrypted metadata in the RTP header. This is probably not news to anyone here. I'm just sort of putting this up for understanding the entire problem space. Beyond like just the header extensions that's talked about. Even if you encrypt the header extensions, the actual IDs of what header extensions are being used, that stuff is still there in clear text. Next slide. So what should we do about it? Let's try to encrypt this stuff. We've already had huge success from RFC or from WebRTC's use of DTS SRTP is mandatory to implement. All that traffic now is fully encrypted, and it's also any other sort of apps that aren't even using WebRTC are actually that traffic is now mostly encrypted in the apps we're using today, including this one, MediaEcho. Next slide. All right. So what can we do? RFC 6904 exists, and what RFC 6904 does is it allows use of the same SRTP keying material to allow encryption of the actual RTP header extension values. As you can see here, the things marked in green are the things that actually get encrypted by this. And while it does encrypt those values, and they can be sort of encrypted individually, all that is negotiated. There's still a fair amount of stuff in like that header that it is not encrypted. Next slide.
Bernard, can you make the slides bigger? Thank you.
All right, so 6904 basically has this mechanism where you, in addition to the headers extensions that you send in SDP that I showed on the first slide, you also, for each one of those, you send an additional proposed header extension that basically is the encrypted form of that particular header extension. And this provides a fair amount of flexibility because you can turn each individual header extension on or off, but it's actually fairly complicated. And all endpoints who support this then need to support this negotiation on an individual basis of which header extensions are used. And then once things are negotiated, then like that particular part of the RTP packet then gets encrypted. We just recently found that libsrtp had a serious bug in its implementation of header encryption, and WebRTC also had a pretty serious bug that caused the behavior of header encryption to be the exact opposite of what you wanted. That when you turned on encryption, it actually failed to negotiate the encryption of the desired header extensions and encrypted the other ones instead. And so this is not a great state. We've heard from implementers that if there's something simpler that they didn't have to do as much work in negotiation and libsrtp just did most of the work, that would be a much better state and they'd be more likely to deploy it. There are also some technical deficiencies in 16904. I won't get into all the details, but the bottom line is that due to the number of header extensions, we run out of 1 byte header extensions, and we would have to go to 2 byte for the encrypted ones, which basically means that encryption wouldn't be free. We'd have to accept some RTP packet bloat if we went down this route trying to use 16904 to do encryption. So next slide. All right, could we find something that was simpler in terms of implementation complexity and also perhaps encrypted more stuff in the packet and didn't have the drawbacks of 16904? And I'm not going to try to get into solutions here because I don't have a ton of time. But if you're interested in this, we're going to have a meeting in 2.5 hours where we'll try to get into those details.
Oh yeah, so that meeting is at I guess noon Eastern time, which is what, 6 to whatever time that is UTC. It's
1500, yeah.
Yeah. So yeah, so that's listed also. That's been mentioned on the. I've just pasted in the chat the link. It's also been on the AVT mailing list, and it's on the side meetings wiki. So if you're interested in that, please join us. Ronnie, I'm letting you in, but you're going to also have to enable your audio as well as your video. Oops. Actually, I think I might have to mute my video. Oh wait, Ronnie, are you trying to share the screen? What are you trying to do? Ronnie, if you wanted to talk, click the microphone icon. All right. If not, we'll move on. All right. Yeah. So anyway, please join us in that meeting at in 2.5 hours. And let's move on to the next. Oh, wait, there's Ronnie. Are you trying to share your slides? What are you trying to do? You can't share slides while Bernard is sharing slides, unfortunately. Ronnie is gone. All right. Yeah. So, all right. Let's move on to the next presenter, which would be Shui.
All right, can you guys hear me? That's not the right one, though. Can you hear me? Okay. All right, that's great. So good morning, good afternoon, good evening. My name is Shui. This presentation is to update the RTP payload for VVC since IETF106. The other authors is Stefan and Iago. Next slide, please. So a short VVC spec update. The FDIS, which is the final draft internal standard, has been out internally in GVET on July this year. It's also consented by ITO. That means it's done, it's proved. Just waiting for the public publication in the ICE website. So we currently have this working group second draft already. Next slide, please. All right, thanks. So since IETF106, here's the following update that we have already had on the second draft. Coding tool is always updated along with this 266 spec. However, the current draft is not a complete finish yet, so we still have a lot of work to do to implement the new update from the FDIS. But I can see that most stuff is done is there. Also, based on the previous agreement we had on IETF106, we had implemented the following. So we only support ST, which is single stream, single transport, based on the feedback that we had, lack of implementation on MRST and MRT mode. We also removed the Pucky header, removed the downlink-based signaling. So this is we have discussed on the IETF106. We have agreed upon. So on the current draft, we also implement the basic SDP section. It's only a skeleton there. We still need more work to be done. Then we also added the new thing we added is the free marking support for VVC. We currently implementing the short and the long versions. So if you do care of free marking, please do pre-reviews. Next slide, please. So one of the things we still have a questions is regarding the RTP feedback message. So we needed to get a consensus on this group, which kind of mode we need to support it. Currently, we think the SOI and the RPSI mode might not be needed due to what we found is not much of implementations. So this is one of the things that we probably going to discuss on the meeting list to see what do you guys think the feedback message for the VVC. Next slide, please. So free marking is a option RTP header extension. We think it's going to be very useful for the VVC payload format due to the nature supporting with temporal and spatial layer support. We have currently implemented both short and long header extension, which is in the section 9, I believe. The syntax is pretty much aligned with the definition of the free marking draft. But so the questions we still have is really, do we need both short and long extensions? So if it is only base layer having encoded, so not sure the short extension, I think it's fair enough. But I doubt it's for the VVC cases is only base layer has been used. So maybe thinking about a pure implementation perspective, do we really need both headers? So those are one of the things we probably discuss on the meeting list. Next slide, please. Sorry, I run pretty quick since this is really obvious things we discuss. Of course, we can go back on the meeting list for the specific topics. So one of the things that we wanted to discuss is really the we call it reserved bit. Sorry, we call it reserved. It's really reserved for us to discuss. For the fragment unit, this 1 byte fragment unit header. Since it's kind of inherited from HEVC, but VVC only support a 5-bit non-header. It's kind of similar situation for AVC. In AVC case, it simply discard the R bit. Nothing to do with it. It's set at 0 all the time. For VVC, so we were asking, what can we use it in a better purposes? The simple idea we probably have is really use the R bit to identify the picture boundaries. Either set it is R1 or 2 to identify if it's the beginning of the picture or end of the picture. But on the other hand, since we have free marking already, but since free marking is optional, right? If free marking is implemented and similar functionality has been provided by free marking, but if it's not implemented, do probably add-on feature, I mean, as a fallback or something like that. So this is one of the things that we want to initiate a discussion, see what we agreed upon that. So it's not really a deal breaker, but you know, something we need to settle. Last slide, please. Next one. So there's still lots of things going on. We still need to update this new draft, the new coding tool update from the FDIS draft. Also, we need to make decisions on free marking. which kind of mode we need to support, or both of them. STB session, we expect we can get a revision very soon after 108. Reviews on that will be much needed. IAM consideration is pretty straightforward, and at the end, I think we target on milestone end of 2020, which is like what, 5 months, 6 months left. I think that's a reasonable time for us to complete the most of the work we discussed here. Last one, change history, which is nothing. That's it.
Or sorry, does anybody have any comments? Stefan. Stefan, go ahead.
Just a little bit more context regarding this picture boundary detection stuff. VVC includes in version 1, in some profiles, scalability. That means that the RTP timestamp can be reliably used to differentiate between access units, meaning pictures of multiple layers with reproduction at the same time, but not between pictures. Now, if you have a regular slice at a slice boundary, a regular packet, not a fragmentation unit, but a regular packet, you can, of course, always take a look at the VVC header structure. So that's relatively easy. However, when you have a fragmentation unit, then you can't easily identify the picture boundaries anymore. And when you lose one of them, when you lose one of those packets, then you know, because of the start and end bits in the fragmentation header, that you lost the fragmentation unit, but you wouldn't know whether you have lost a picture boundary in between. And then, you get into all kinds of trouble in identifying what state you have with the on the decoder side, whether there is only a layer damage, only a higher layer damage, then you just move on by decoding only the lower layers, and so on, or whether you would need to really basically reset your decoder because your base layer feature is damaged, and you have to start from scratch and full intro and all that. So that's the rationale there behind using this bit, and the rationale why we think we can get away with it in the fragmentation unit header only, and not in every single packet where we would, in that case, need additional an additional byte header structure, which we don't want to spend. Now so that's the rationale behind it. Thank you.
All right. So yeah, I mean, I guess anybody reviewing the draft, please keep that in mind, particularly about trying to figure out the issues there with packet loss and scalable structures. Any other comments on that, or can we move on to EVC? We're kind of over time, so.
All right, it's me again. So again, Good morning, good afternoon, and good evening. So maybe good night for other people. So here's the very short update for the EVC draft update. Basic introduction. So it's EVC stands for essential video coding, similar with other hybrid coding like 26264, 266 as a common coding tools, but with a different level of support. It is done by IPAC. The final draft, it's internally published on April, so it's also done. The existence of the EVC is expected to provide better transparent licensing options with target on different customers. It has two profiles: a base profile, which is free of charge, of course with less effective performance. Main profile, which is not free, I mean with advanced features. Compared to the coding efficiency compared to EVG, I would say is better than HEVC, but you can look up the status online. It also has a 2-byte header unit design, similar with HEVC and VVC. There's nothing new here. So one thing needed to be pointed out that EVC only support temporal scalability. So it might have a little bit impact on the things we can do in this draft, like frame marking. Also similar parameter set like SPS, APS, so nothing fancy here as well. If you want to know more about coding tool, just please look at the draft. It has most of the coding instructions there. Next slide, please. So since this is still an individual draft, the way we approach VVC payload format is really following the idea, the discussion we had on the VVC, which is only support SRT, remove the PAT-key, and remove the DANI. But of course, this is not being discussed in the Middle East. Unless everybody has comment, some stuff need to support it for VVC, please comment on the draft. Next one. So what has been done in current draft? So this is the summary. Basically, coding tools, as mentioned as already, we still needed to finalize along with the FDIS draft, and we implemented non-header, which is trivial. We also implemented the payload structure as implemented based on the FDIS. Next slide, which is the last one. Sorry, we'll go so quickly unless you guys have any questions. So here's the questions that is open issue we want to discuss if free marking is really needed at all. So since it's optional, so we wanted to ask, and then this VVC is only supported temporal scalability, would that be overkill? Right, so we haven't implemented anything yet, but this is something people can express their opinions. Similar question on the RTP, RDCP feedback messages. So we only put the placeholder there, we haven't implemented anything. Overall, I think this draft is in pretty good shape as the basic stuff is implementation is there. So we would like to ask if this current draft content would be acceptable as a working group draft. The final target milestone will be, I think, early 2020, pretty much after VVC draft. So that's this both spec has been finalized, right? No substantial change will be made. Yeah, so that's it.
So I guess first, speaking as an individual, this is entirely in scope of the payload stuff, and I'd also say that insofar as the high-level syntaxes are the same, the payload should ideally be the same as VVC because there's no reason to make them different. They're obviously related specifications, and they're both our current notion of what's the desirable state of the art. Anybody else have any?
We're glad we make a cleaner design for the VVC, so hopefully this is acceptable for the VVC as well.
That I'd expect. Anybody else have any comments? If not, we'll do a call for adoption for make this a working group item on the list.
Stefan has something to say.
Stefan, oh yes, sorry.
Know how widely frame marking gets deployed. I mean, it was all on Ovoke about 2 years ago, but I haven't seen many frame marking bits on any wire or anywhere. Anyone has any opinion about that? That's also the rationale behind that question there.
It was just removed from WebRTC a few weeks ago. So I think that was the major implementation of it, and that is gone now.
Does also apply VVC draft as well.
Yeah. All right. Yeah. So I mean, which might have implications on other points of the draft, making sure we have the information necessary elsewhere.
So I'll take an action item to start a discussion on the list. How important frame marking is nowadays.
Sounds good. Thank you. All right, last presentation is Bernard. Hopefully won't get cut off.
Okay, so this is about multiplexing updates for Quick. We've had a couple of sessions on this, just recapping what we said at IETF 103. The idea is to use Quick as a transport for peer-to-peer data transfer in WebRTC. This could be reliable transport, such as a file transfer friendly with audio video, or it could be unreliable. This has been proved very popular in gaming, which basically wants UDP for the web, So basically, you can have web games communicating things like location, position, stuff like that, typically using the Quick datagram extension to Quick. And of course, WebRTC applications multiplex, SRTP, SRTCP, stun, DTLS on the same socket as in RFC 7983. So a little bit of history. Again, this was covered in IETF 103. So Colin Perkins and Lars first noticed the incompatibility of Quick transport with RFC 7983 in March of 2017. We had a presentation at IETF 100 in AVTCORE. A solution was proposed then and was merged into Quick Transport Draft 08. And they confirmed they wanted to do this. There were some issues found which were discussed at IETF 103. Those were issues in Quick Transport 16. They were fixed in 17. And since then, the solution has remained stable and is in the draft 29, which is the latest one that's been implemented. And that scheme is documented in this internet draft, AVTCORE Quick Multiplexing. So here's a brief summary of the way things work in the current Quick Transport draft. Basically, what you can see here is there are two types of Quick packets. There's the short header packets and the long header packets. The long header ones take up the code space 192 to 255, and the short header 64 to 127. There is an overlap with turn channel. This is not a big issue, at least in WebRTC, because turn channel is not implemented there. So this is basically what the multiplexing scheme is. And since that description, we've had some increasing traction. There was a peer-to-peer origin trial in Chrome and Edge beta that was M73 to 75. That was based on some JavaScript APIs that were under development in W3C. And at that time, that trial was based on gquick, which could not multiplex. But it did support the basic features of Quick, bidirectional, unidirectional streams, as well as datagrams. And since then, including in current versions of Chrome and Edge, there is a Quick Transport origin trial, which is client-server. This API has been updated to support WG streams. This implementation origin trial is compatible with the Transport 29 if you look at M85 or later. And AIO Quick is this server side, so everything works. And again, it's this has full support for all of the Quick functionality, including streams and datagrams. So given that we have a multiplexing spec, it's implemented in the, the Quick Transport 29, which has it, is out in the field. Why can't we just declare victory? Well, the problem is that this Quick Multiplexing is not documented in RFC 7983 because that was published before this stuff came out. And it's only documented in an internet draft. And history shows that undocumented agreements have a low probability of working out. Something's going to go wrong because you don't document the requirements in the ANA registry, so you can't flag the conflicting allocations or even know what documents are applicable. And also, I've had various requests for developers, hey, what's the multiplexing scheme? I don't see this in 7983. So you're going to have probably interoperability problems because people won't understand what to do. So we've had these origin trials, and so we're rapidly approaching an inflection point. Quick Transport is out there. It's being used. It's pretty easy to implement. So at some point, stuff is probably going to ship. And once you have the client-server version out there, it's pretty easy to reuse it for peer-to-peer, and a bunch of people are doing that as well. And then they'll depend on this multiplexing stuff to work. And if it doesn't work, there will be consequences. So we want to avoid that if possible. So we have this RFC 7983 BIS draft, and basically it has a couple of purposes. One is to update RFC 7983 Section 7, just to document what the multiplexing scheme is that is supported in the transport draft, and also provide a little bit of guidance on handling overlap between Quick and turn channels. It's not an issue for WebRTC, as I said. I'm not sure it's really an issue for anybody else, but I think it's fairly easy to handle if anyone cares. And the second thing is just to update the DTLS content type field IANA page. I don't think any changes to the page are needed in terms of the allocations, but it needs to reference the right RFC. So when people look at that, they'll know where to go to understand what the multiplexing scheme is. Now, one caveat for this, in Quick Transport, we did talk about this, and the agreement really only applies to Quick version 1. New versions of Quick are allowed to change aspects of the wire image, so there's no guarantee that future versions of Quick will adhere to this multiplexing scheme. But so we just want to make clear it only applies to version 1. So what I'd like to ask the working group to do, I don't think we have time to do it now, but is can we adopt this as a working group work item? And here's a little bit of review of what's in the DTLS content type field. Basically, I don't think any of these assignments need to change. All it needs to happen is to reference 7983 bis instead of 7983 so people can understand what the scheme is. But everything else is fine in terms of the assignments.
Yeah, so as mentioned, we're over time and Mitako needs to close the room so they can start streaming the next session. But I think it seems to me, I will do a call on the list to ask if you want to adopt this. Also probably, they don't think we have a number of the key participants there, which we need to get a few of them in. I know there's some discussion whether the qubit is sticking around or not. So we'll do a call on the list. I'll probably do that since Bernard's an author. So we're doing this. And since we are indeed 12 minutes over time, that's it. Thank everybody for coming. And we will see you probably virtually in virtual Bangkok. Thank you, everybody.
Thank you.